Welcome back everyone, it's episode 3 of our Sedgwick hybrid home and we're airtight. We've had an initial blower door done and we've hit 0.55 air changes an hour at 50 pascals. And we want to take you through now and show you all of the inside airtight detailing. This is another plasterboard airtight home. We're excited to show you what we've been able to achieve and how we've done it.
So as Anthony said, we've achieved a really good air tightness with this home, and one way we're able to do that is with lift and slide doors. In a standard home with sliding doors, you do get a little bit of leakage underneath just the sliding part of the door, and to overcome that, we use lift and slide doors. So this is Ultimate Windows, Zendow range, low E coating and double glazing, and they're very operable. All you need to do is just this crank handle, as Anthony does as well, and slide. So as you can see, that crank handle lifts the door up and puts on a set of wheels. And as you see, we close it, it just drops it down onto a rubber gasket, and that way it's airtight. Do you want to chat, Anthony, about how we did the air tightness with the portals?
Yeah, certainly. So these portal frames are actually structural, so they're not just aesthetics. And they're supporting the roof purlins that are running straight over the top of us directionally here. And the problem that we have with this is, being that they're structural and we've got to install or construct the roof on top of them, is they need to be installed prior to the plasterboard airtight layer. So there's a little method that incorporates what we call a starter strip, which is part of the external building wrap, is cut into a thin strip and it's installed on the back side of this portal frame so that we can come along at a later date and then install the plasterboard to it using a continuous polyurethane bead, and then it gets sealed to the plasterboard and the wrap, and now that's a continuous airtight seal that goes from this plasterboard behind the portal frame and then continues onto the plasterboard on the other side.
And we've done something very similar with the ceiling, the portals going across the ceiling. Instead of using a starter strip, we just used 17mm plywood, and the reason that we use plywood instead of just a starter strip is that the 17mm works really good with our 16mm ceiling batting up the top there. So yeah, it's a good little touch there. And what about like the plasterboard air tightness around power points and wires that come through?
Yeah, so we've used our airtight boxes again here, like we did at our previous project. So they've all been sealed on the faceplate to the plasterboard with some polyurethane again, and the cabling that's coming through is also continuously sealed where it comes through, and the penetration at the hole at the back. But they're fantastic. You know, we've used those on a couple of projects now, and again with the blower door testing, they've all been completely airtight. The other thing I think we need to just talk about maybe is just where you don't have a GPO, like a general power outlet or a light switch, and you do have an electrical supply required, such as a light. For example, we've got wall-mounted lights right along, highlighting all the portal timber frames, and you've just sealed around the penetrations to those cables as well.
That's it, and same thing, ceiling lights and that sort of thing. If it's surface mounted, you can generally just polyurethane the plasterboard to the wire, and that's fine, sufficient. The electricians don't have any issues. If it is a downlight that needs to be concealed in the roof cavity, we just slot on plywood boxes on top. So
and I mean, we've been really mindful with this project. Majority of the lighting in here is surface mounted, so there's very few airtight containers required for any downlights. In fact, I don't think there is a recessed downlight in the projects.
No.
So one of the most important things we need to consider when you do create or build an airtight home is how you're going to ventilate it. So having an internal ventilation strategy is critical. We can see up the top here, we've got 2 bulkhead grill extracts for fresh air supply from our heat recovery ventilation system, which is continuously providing fresh filtered air 24/7. We then also need to ensure that we have extracts, which is this particular unit here, which is mounted to the ceiling, and that's going to be our extract for taking out humid air and odours in that air as well, and putting it outside via the HRV system. The great thing about that is as you're cooking and it's obviously creating a lot of energy and heat, that hot air is taken to the heat exchanger in the HRV system, and then it goes through an exchanger, heats up that incoming colder air to a warmer temperature, and then reduces the requirements for additional heating and cooling. We do have a wood stove as well in this project, which is, always comes with its challenges when you have an airtight home. And what we can see here is the intake pipe that's going to be providing the air supply to the chamber, the wood heater, wood stove chamber, for where that'll allow its own air supply to work.
Yeah, because traditionally the wood heaters draw from the internal part of the house, and obviously being airtight, that's going to cause issues and put pressure on our system. So we need to have a make-up air.
Yeah, exactly. And that's probably good chances to touch on, but we'll go into further detail at a later date. We have got a range hood here that just vents directly to outside air. So it's a particular system that has its own fresh air supply built into the front. So it is bringing its own air supply in, but it's at a lower rate than what's being extracted. And it's a traditional range hood that's extracting. And the reason for that is so that its cone, or its ability to pick up off the edges of the hot plate or the cooktop are sufficient. But if we balance that out and we have the same air supply coming in that was being extracted, it would narrow that field down to a point where it wasn't effectively operating. So we're going to work out and talk about in more detail at a later date how we're going to supply enough air to make that more balanced, but also perform optimally and extract at the rates we need it to.
And make it airtight too.
And make it airtight too,
So as Anthony was just touching on, the HRV ducting, it's all concealed within our plaster, or the plaster you see now. So the HRV ducting, it needs to be within your thermal envelope, and that's to minimise any condensation that may form if it was outside the thermal envelope. And it's really important too to make sure it's included in your airtight system. It can be done out of the airtight system, but it can cause a lot of complexities going inside and outside your airtight system. So the solution that we come up with here in our other project in Castlemaine is, and it's very common, it's just the 140 blocks, and they're just offcuts of our timber studs, cut to a triangle. That creates a nice void from that plaster ceiling you see there to the second plaster ceiling, and it gives a good opportunity for the HRV ducting to run through there, and also the wires, there's a little bit of a cavity there for them and that. So
yeah, and I mean, I think if we break it down, I think we were able to get airtight in around 2 to 2.5 days here using the plasterboard system. So it can be quite quick compared to other methods.
Yep. This method seems to work well for my business and what we do. So yeah.
I might step over and maybe just walk away from the performance aspect and have a look at some of the thought that's gone into the construction, just general construction detailing. One of the things that we often get asked when we're designing on paper is, placement of cavity sliding doors. And one of the things I suppose that people are concerned about is when a cavity sliding door intersects another wall or joins another wall. It's quite easy to do, and you can see you've done it really well here. You've just had a bit of forward thinking where you've put in a little bit of plywood, additional plywood to be able to pick up plasterboard.
That's right,
And there's a fridge located here too. So what else have you had to do to consider
so it's a fridge, but it's also a fridge with a water point. So you need, the plumber to rough in. So roughing in's where they run their pipe work inside the wall cavity. Traditionally a water point would be mounted just above the fridge height, and because we've got the cavity sliding door there, obviously that doesn't work. But a little bit of thinking, if we just put it right up the top of the frame up there, and it's just at the top corner of the cupboard, the plumbers may need to install a little bit of extension on it, but it's no real biggie. And the other thing with a fridge, obviously you require power. So traditionally, again, power is going to be located where that cavity slider is, but we've got a cupboard next to it, so it's just been installed in the cupboard next to it, and then we'll just have to drill a hole through. That way, power can be connected to the fridge.
Fantastic. I've just mentioned before that we've had Ultimate Windows supply the doors and windows at the home. I thought we'd just take another opportunity just to showcase a tilt and turn window, which is a bit uncommon in Australia. It's pretty common in our little niche. But So it has two functions. So the first one is, it locks in. It has multiple locking points all the way around, which creates that airtight seal that we're after. And if we just do a half turn, it allows it to open up like a traditional casement window might, but opposite. It opens in instead of out, which is great to clean the windows. And the fly screens go on the outside. And then we also have the tilt function, which is great for night purging or just keeping ventilation occurring naturally, especially if you're in a built-up area and you're worried about security as well. So another really cool item in the home.
And do you just want to explain to everyone how you're designed this home for cross ventilation? That's something I know that was a big part with not just cross ventilation, but the view and that's the thing.
Yeah, of course. So I think in the first episode I just mentioned we have prevailing wind patterns that come up the gully just behind us here, and they're coming from the sort of southwesterly direction, and we've aligned the windows, or the openable portions of the windows, to be adjacent from each other, or across a line from each other. So we can open this window here now, and there's one directly behind us that we're looking at now that we can open as well, and it'll create that cross-flow ventilation through the home and just assist in naturally cooling the home. One of the other things that we're really fond of is trying to have a really thermal bridge or reduction in thermal bridging in a home in its design. And we have a really high wind rating here on top of the hill. So there's a few of these, what we call a power truss bracing system, which are made out of metal, and they're quite compact, but they provide a huge bracing capacity. And being metal, it's a high thermal conductor of heat. So we've put the 50mm XPS board on the outside face of that steel frame, and that's now thermally broken. So that it's really reduced that heat transfer from occurring. And then what we can do...
It's a good little touch too, because it's just off-cut of building material from when we did the slab, so...
Exactly right, and we know, I think we've highlighted that in that second, that first episode as well, but then we can just insulate in between in those webs, and we've kind of got that XPS on the outside, and then just the bulk insulation in between. One of the nifty design items are these really full height stacking cavity sliding door systems. Did you want to maybe
so we're currently in a multi-purpose room. So this room's purpose for the family will be a study, guest bedroom, a bit of a kids retreat and that sort of thing. So the whole idea is that they want to be fully multi-purpose, and with that comes the opportunity to sort of create it as a sort of open living room as well. So Anthony, the team has designed these 2 sliding doors. So a door will pocket across to this hardwood Australian spotted gum post that's sort of been intentionally left with the saw marks in it, give a bit of a rustic sort of feel. And then they've got the opportunity to close this room off when they have guests come in, or when one of the parents is working from home. Close that off. And obviously this will all be finished off with plasterboard and all square set and nice and neat.
Yeah, and look, we have a few material linings in the home. There's a little bit of plasterboard, but one of the items in the client brief was to try and have as many durable, hard-wearing internal surfaces as possible. So there's going to be a couple more. There's a natural timber lining that'll be going inside of the vestibules or the jut-outs that we've looked at previously as well. But there's also going to be some VJ hard-lined panelling going down the remainder of the home. And the trick to getting those airtight, I think, is it's had to have a little bit of thought in the details as well. Yeah,
definitely. So we're treating the VJ panelling, which comes in about 1200, so 1.2 metres and 2.7 metre high sheets. Similar plasterboard that we're just going to seal the perimeter of each sheet and seal the joints and that sort of thing. And then any there we do have any wires, and we're just going to use airtight boxes. But with the natural line timber in these pods, with the spacings of them and being a natural product, that we're concerned come different times of the year that they may create air leakage. So we'll actually wrap that with a building fabric that's going to be all taped and sealed to get it airtight. So,
fantastic. So we have probably highlighted this in our previous series, our Custom Aim project. But the internal walls of this home are all framed secondary to the ceiling plaster being installed. So all the external walls and load-bearing walls were constructed first. We're then able to come through, line the entire ceiling with plasterboard, and then we come in and build the internal walls and install those directly under the plaster. So there's a few proprietary fixings that would be used traditionally. However, we weren't able to do that, but there's some products that we've been able to incorporate here to achieve that airtightness.
So as Anthony said, the plastered ceiling's all right through, and that's done before all internal walls. So traditionally, to make a home structurally sound, that you're required to use a product, it's called a little L bracket. Just a little metal bracket that normally gets put to the top plate and then up to a side of a noggin or a truss. But instead of just using an L bracket, we use these screws from Simpson Strong Ties, and they just go up through the plate and then pinned into the truss or a noggin up there to straighten that stud, to straighten the wall plates. With doing the 2 sort of wall framing, we are required to do sort of 2 rough-ins. So my trades do, plumber, electrician, HRV guys come do a sort of initial rough-in, and the electricians just hang wires down, the plumbers just put little droppers down, and then the plasterers come after that and they just hang all the ceiling. The plasterers actually love it because it's great, because it's just like a big warehouse for them. They're not required to cut sheets to each room and each walls. It's just a continuous sort of perimeter and ceiling that they hang all 6 metre sheets, so it's pretty fast moving for them, and that they really enjoy it. So,
and being that there are 2 stages to the construction of the wall frames and bracing, is it a 2-stage frame inspection?
Yes, that's right, yes. Well? Yep, so inspector comes, does the external wall frame and truss frame, and then he just pops back later. A lot of people think internal walls aren't actually part of your structural structure. Like, they're probably not load bearing, but from a bracing perspective, they definitely are part of the structural.
And, just touch on the fact that we do have a really high wind rating up here on top of the hill, so it was pretty crucial for us to have those internal walls providing that bracing or aiding to that bracing capacity of the overall home. I did want to mention too that we blower door test a lot, and the screws penetrating the plasterboard, which we've just said is the airtight control layer of the home. We wanted to ensure that that had no reduction of the airtightness, which it hasn't. And further to that, when we blower doored the previous custom main project, after all the pictures had been hung and there's nails and screws through all the plasterboard, had absolutely zero reduction of the airtightness factor of the home and the results. So
because we do penetrate a lot of screws for our plasterboard to keep building the home. That's the thing. Like, you can see all these 140 mil blocks. There's probably 1,000 screws or 500 screws that have been penetrated for our plaster and that, but they don't have an impact on it. I sort of think with airtightness with building fabric or plasterboard, it's fine, obviously when it's all continuous. If you drill a hole through it and don't put a screw or nail in that hole, that's an air leak. But if you fill that hole with a nail or a screw, then that's seals it up so it's airtight and watertight. So
the focus of ours as well in more recent years has been about the livability and aging in place for a home and the occupants of that home. You've been able to install some of this plywood here, David. Like, what was the intention?
Yeah, so it's just come from a request from the owner. This is his forever home, and years to come and that thing, he just doesn't know whether there could be a need for any future grab rails and that sort of thing. So showers around the toilets and that, we just installed plywood noggins in behind it. And I do know as of next year with the new National Construction Code coming in that it's going to become mandatory to start sort of installing noggins, that sort of thing, for the ageing population. I'm glad you touched on that. So in Victoria, for example, May next year, Victoria will adopt the National Construction Code requirement for livable housing provisions, and as part of that, it does stipulate exactly what you must do to achieve that, and it has the size and thickness of the plywood and where it needs to be located. Another thing that is mentioned in that provision is a clear opening to allow accessible access, or improve the access to a shower. So if you do have a glass screen, it's one of those bathrooms or showers must have that glass be removed at any time in the future to be able to provide a lot more ambient access. So clear thresholds as well, so we don't want to have any steps in any of those locations. That's right.
So keeping in mind, if you're using showers with bases, that at least one of those in the home should be level, flush entry.
I'll just touch on here. You can see that we've got this piece of masonite packer in there, and that may look like it's a mistake. It's definitely not. That serves a very crucial part of our waterproofing system. So the waterproofing membrane will be installed down this wall. Sorry, it'll be plastered first. The waterproofing membrane will then go over top of the plaster. So with the waterproofing membrane, you don't want them to be continuously sitting and soaking in water. So the idea is this packer at the back here, when the plaster gets installed, that will be installed with a little bit of fall on the plasterboard. So then that waterproofing membrane has a little bit of fall on it. So then if water does spray out of our shower, gets through the tiles, which tiles are porous and they do soak up water, that water can drain. It doesn't sit there constantly, so it gives the ability to dry.
So you've got a good amount of fall on that. This will be a shelf in the shower to put your shampoo bottles and whatnot on top, and you've got a good amount of fall on that's going to drain it down to the floor waste if it does.
I'm a really big fan of trying to improve the bulk water management of each home we do and that sort of thing. Like I heard an American architect from the build show, Steve Basic, say the other day, it doesn't matter if you build the best passive house, a high performance home, if then you've got water issues, that's still not a great home. So I just want to take the opportunity to show you sort of what I call our central hub here. So this is sort of a job organisation, site office, OH&S sort of fire extinguisher, that sort of thing. So here's just it's actually a cabinet on caster wheels that we can wheel room to room, because next week this slab here is going to be burnished. So this is all going to get relocated into another room where it's not getting burnished. But in here, just a bit of safety, fire, screws. It's good the boys can go any stage, get what they need. So that's sort of bulk storage. If we move around the other side here, again, it's pretty agricultural, but it's just an offcut of an old door. But this is sort of our office. The boys can go access plans any stage. You know, we've got outliers, internal set with all the joinery details, then sort of structural engineering, and then the architectural set. And then this is all sort of our lock-up information that just gets put into a manila folder with all the details of all the appliances, plumbing fixtures and whatnot. And then again, we've just got a nice little a whiteboard here with to-do list. So again, this is all sort of varies, but we've got like an inside sort of list, outside list, anytime list, and just any sort of notes and that sort of thing. So yeah, and big on organisation, making sure the job flows smoothly. So Anthony, this is a pretty cool little space here. Would you mind explaining to us what the whole design and purpose of this space is?
Yeah, certainly. So because where we've started up the very end, the living space is north, we're heading down to the southern end of the home now. And to try and get that northern light into these spaces, we've had these little vestibules or jut outs put into the design. And so the window that we're looking at now is facing north, and that's bringing the light onto us now from that northern aspect. But what it also allows us to do is have these little breakout spaces. So we have the children's bedrooms off to my left, and they can use this as an extension of their bedrooms now as a bit of a day bed and a hangout space. And still get, you know, that beautiful easterly morning sun and the northern sun in during the day. As part of that, the brief from the client was to incorporate a little wood heater into the space. So they're going to have that in this little bit here, and we've got a pipe just here. And what that is the air supply down into the wood heater. So it'll have a traditional flue, and the tricky part about that again is not just having that fresh or that makeup or supply air to the wood heater so it actually works and optimally works, is also making sure it's airtight. So we're going to basically move down a little bit now and keep following what you can see over our head with the ventilation. And have a look into the laundry where the actual HRV or the mechanical ventilation system or the lung of the homes is going to be.
You can see as we come further down too, there's a lot more ducts because we're getting close to the actual unit. So with construction here, we actually had to alter away from using our triangle offcuts of 140 framing studs, and we actually had to put ceiling joists in here, so just some pine on its flat to accommodate all the ducts with the triangles. There wasn't enough space in this hallway, so yeah. No,
it works well. And there is a change in the height of the ceilings here. In the bedroom here, we don't need to lower the ceiling like we might have to if we had a dedicated internal airtight barrier or membrane. We only need to lower where the duct runs are going to be. So we've got 2.7 metres here, which is a plaster on the bottom of the bottom quarter of the truss, and then it drops down to 2550 here in the passageway, which is enough clearance for us to run our ducts for the HRV system.
So what's the purpose, Anthony, with the extract systems? Why are they mounted on the ceiling?
So the extraction systems are mounted on the ceiling so that we can place them as close as we need to where the source of the humidity or odours is going to be. That's what we'll see in a minute. It's located directly over where the shower location is or the cooking station. And the great thing about those is that there is a momentary switch that we use, which would be in lieu of your traditional exhaust fan switch, which once you hit that, it'll flick back on and it'll turn the HRV system on to a higher flow rate, or boost mode as it's commonly known. And that'll do that for typically 30 minutes and really assist in getting rid of that excess humidity out of the home and any odours. One of the things that we've noted with the data collection that we've been doing with our previous project is that the indoor relative humidity levels will sit stable at all times of the year between about 40 and 60% RI. A great thing about that is that that's kind of in that thermal comfort level, or optimum thermal comfort level, and it's also at a humidity rate that is really likely to reduce the likeliness of mould growth and things like as well as creating a much higher indoor air quality overall.
So, like, obviously this home's airtight, so we can't really use a standard manhole surround. Well, you can, but we just had to come up with something a little bit tricky to get it airtight. So directly above me here, there's a manhole chute that goes up to their full 2.7 high ceiling, so airtight plaster ceiling. It does look relatively agricultural and industrial, but so the way that's going to be finished is there'll just be a standard manhole plastic surround installed on the underside of the plasterboard that you'd see in a standard home. A piece of melamine gets positioned in there. So you sort of have the two hatches. One hatch is just a cosmetics hatch, and then the other hatch is a industrial hatch that's airtight. airtight. So, and I think for the sake of how many times once you actually move into a home that you get up in the ceiling, it's not too much of an issue. So
yeah. And again, you know, we've run the blower door on that exact system multiple times, and it's been airtight.
Yeah.
So yeah, all of the ducts run to this single location we can see here, which is where the actual heat recovery ventilation system unit will be installed.
Yep.
And we need a little bit of space for that. We typically allow about 700 millimetres by 900 millimetres for the cabinetry internal to install that system. Any condensation that does occur in that exchanger, as we do have, you know, say a colder outdoor air and a warmer air passing each other, will run through and out and disperse by this condensation drain. Just there, we'll fix that in a moment.
Yep.
And then we've also got the two larger circles on the wall there. One is the intake and one is the extract.
Yep.
And yeah, they're distributed via manifolds that basically plug into the top of the unit itself and then distribute to these above us.
Yep. And this is the laundry, by the way, too. So it's sort of away from the master bedroom that you're not going to, not the HRVs allowed, but you know, they're away from, you know, the sleeping quarters and that sort of thing. So,
yeah, I'm glad you touched on that, because it is one of the most common questions that we get. Is no one really cares to ask, firstly, what, you know, what kind of relative indoor humidity levels we have, or how much the filtration system actually picks up and whatnot. But the first question we get is, how loud are they? Yeah. And I can safely say that they are not at all noticeable. With the joinery closed, you wouldn't hear it as we're standing here at all as it operates. It's a very, very slow, low flow rate. It doesn't have a high speed fan or anything as such, so very, very low.
But I think if you are looking to build or design, whoever you're building and designing with, reach out to them and have a go to like one of their past homes that does have one operable and that sort of thing to get your own sort of take on it, to know how, you know, quiet it is, let's say.
Yeah, and we might even do another video at a later date with it operating so everyone can hear for themselves. So another question we get often is, you know, what heating and cooling is required in a home, in a high performance or passive home? And you do require heating and cooling, auxiliary heating and cooling, but you don't require anywhere near the capacity that you traditionally would need. So we have a little cable or some piping coming in here, and this is going to be a reverse cycle split air system, so it is an air source heat pump, and there's another one of these in the open plan living. Now these two systems, this is the one of the open plan living is 3.5 kilowatt, and I believe this one is as well. And when you've got one internalised like this, and you are on a rural property where we do have a septic tank, you must make allowance for the condensate that occurs here as well. So we can't just run this out and discharge it into the stormwater system, because that's going to go to the rainwater tanks. Yeah. What have we done here, David?
Yeah, so we're just actually gone into the sewer system. So there's a condensation drain running down here, and we've got a vanity just on the other side of this room here, so that will go straight into the sewer. It's one of those things, like you could potentially just have a little, you know, dripper going out in the ground, but again, it's just not best practice, and you know, we don't want to do that. I'll just touch on, you can see that here's that laundry that we just spoke about, where the unit is, and we are required to have a duct in the ensuite here, and as Anthony just chatted about the reason why it's directly over the top of the shower. So we need to run ducting from that room to that room. So to do that, we just drop the whole ceiling in this walk-in robe, and we're not required to have any ventilation or fresh air in there, because it's not a habitable room. So yeah, we just chose to drop this whole ceiling here. You could do an option like a bulkhead sort of system across one wall or even the outer perimeter, but yeah, there's plenty of different options about the best way to go about it. So standing outside the home, and I want to chat to you about how we detailed this building wrap. So you can see, as I've showed you in the previous videos, that we have that double bottom plate. The very bottom plate's our air seal plate. So polyurethane the building wrap to that air seal plate. The building wrap runs about 50 mil lower than that plate. So the idea is that the polyurethane is taking care of air tightness, but with water management, the building wrap goes right down to 50 mil below. That way the condensation that forms on this building wrap doesn't, you know, go up into a timber plate at all. Anywhere that we've got any joins, it's all nice and sealed with tape. Again, just from water management, but also air management. And this is like the wind jacket of the insulation. That's something if you ever stood outside on a cold day, like it is today, with a woolen jumper, that wind just blows straight through it. So this is the whole purpose of it. And anywhere that we've got any sort of penetration, this is a good example here, that we've got the hot water unit going here. All the penetrations have been sealed up, all the wires and that way it's all, you know, airtight and watertight. You can see right at the top here that we have another different wrap going up there. So that there is where our top plate finishes, and the other side of that wrap will be insulation. So again, as I said, that like the wind will blow through insulation and have a wind washing effect on it. I'll let Anthony chat about the whole purpose of the ventilated cavity and wind moving around the home.
Yeah, sure. So we got the smoke machine or fog machine out at our previous project, and we tested the cavities extensively. We filled them up, and we noted which direction and how things were moving on different orientations of the home. So that on the north had a lot of sun exposure, and it was able to create that heat stack effect. So we watched it rise, and we could actively see the drying capacity that ventilated cavity was able to provide. But on the southern side, what was interesting to us was when we filled that cavity with fog or smoke, that it worked negatively. So because we have a ventilated ridge capping, and because we're using a ventilated roof space as opposed to a cavity under the roof sheeting here, we have a pressure differentiation occurring, and it's coming down our ventilated cavity on our wall, and it was pushing that fog out and across in horizontal directions as well. And so this time around, we've decided that we're going to just use smaller sections of timber for the ventilated cavity batten here, so we can provide a horizontal movement, or allow horizontal air to move and increase that drying capacity. So yeah, on these ones here, a minimum 20-25 millimeters is generally the rule of thumb that we want to use here to provide enough aperture for the drying capacity we need for this wall assembly. And that then can go up and over that wind protective barrier of wrap up there that stops the wind washing and reduction of the efficiency of the ceiling insulation, and into that roof space, and then up and out the ventilated cavity or the ventilated ridge capping. When you do have a ventilated cavity, it's important to make sure you've got ember protection for any bushfire requirements, as well as for any bugs or rodent protection. So we just have that fine mesh here on the bottom, and as that cladding gets put on, it'll tie that in nicely.
Yep. I think too with the ventilated cavity as well, like it's really important to think like that your cladding will most likely get penetrated by water at some stage, whether that's over a longevity of time of the material breaking down or joins and connections breaking down, or whether it's someone pressure washing your home to clean it.
Could be that.
So that's why it's really important to detail all of this, your membranes and that, so it's going to stand up and it's not going to rot your frame away. And I think also another beauty of the ventilated cavity is that your cladding is, well in this case, 55 mil away from our wall frame and our building wrap. So it's any condensation that falls on that is then just going to drip right down the back of that cladding and not going to touch that frame at all. So
this is a different wrap to the previous project that we used, and for us, I guess we don't have no brand alliance. We're quite brand neutral in our approach to things, and we really want to just, I guess, trial out different products, high performance products, and just see where things are best situated for individual projects and be able to advise on those sort of things. So this particular product here is a medium duty wrap, which means it can be used on the roof, and because we have a cathedral ceiling here, we have got a ventilated cavity under the roof sheet up there, so we've wrapped up the walls and continue that onto the roof. But in this instance here, where we have the change to the other wrap up here, the Benjamin Ogdyke, that's the ventilated roof space as opposed to the cavity.
Yeah, it's just two different approaches, isn't it, which we go back to another episode and have a look how we chat about that, but yeah.
And it's got a nice tight weave throughout it. It's a porous wrap as well, so it's got a high permeance level, which is what we want, because as our vapor drives occurring from inside in the warmer aspect of the, when it's warmer inside and it's pushing out to get out to the cold, and that energy transfer is occurring, and if it's taking any moisture with it as well as vapor, it's nice and permeable, and it's going to allow it out. I think under the National Construction Code, the Class 4 vapor permeable wraps must be used in these climate zones in 6-7, and it has a UG value of I think around 1.3, whereas this is more than double that, so very vapor open.
Yep.
Another question we get a lot of is when you install or frame your internal walls secondary, how do you brace? So there are a lot of temporary braces. You can see one just over my head here. So you do just keep your braces, your temporary bracing in place until those internal walls are framed.
Yeah. I think with this home too, it's such with the makeup of the land that the design accommodated a really long, skinny sort of home. So being so long and skinny, we didn't have too many internal walls that way. So that's why you probably see more sort of temporary braces, that sort of thing, than you maybe would on other builds. Yep. Thanks for watching our third episode of this series, guys. Please let us know if you have any questions or any comments on that. We're really enjoying putting this content together. So,
yeah, look, we'd really love to hear from you. If you've found value in what we've been doing, like and subscribe or reach out. We'd love to be able to continue doing this and providing great content for all of you to watch.